Okay, Year 11, this is our fourth lesson for the topic Arithmetic and Algebra, and we've got a pretty big lesson. Again, it's on equations. So we are getting close. We've covered real numbers, absolute value, expanding and factorizing, algebraic fractions, and surds and indices. And in this lesson, we're going to look at linear equations, quadratic equations, the quadratic formula, inequalities, absolute value equations, and literal equations. So let's start with two-step linear equations. Now I'm going to move quite quickly through this, so if you need extra help, you need to go back to a year 9 or 10 video. 2x plus 1 is equal to 7. Now remember, when we're solving equations, we want to get the pronumeral by itself on the left-hand side, which in this case means I need to move this 2 and this 1. And here's the general rule: move the number most by itself first, which of course in this case is the 1. So I'm going to do opposite operations, subtract 1 from both sides. But effectively that is the same as moving this plus 1 over the other side, and it becomes its opposite operation. Now we're going to rewrite it. 2x is equal to 6. We can solve that by inspection. That just means by looking at it. 2 lots of what is equal to 6. Or we can divide both sides by the 2. And our answer is x is equal to 3. How about this one? X plus 4 all over 3 is equal to 7. Again, I want to get x by itself. I need to move the 4 and the 3, but this time the 3 is most by itself. So I'm going to times both sides by that 3. And rewriting it, x plus 4 is equal to 21. Taking that 4 over the other side, x is equal to 17. Let's try a couple more. X over 2, take away 5 is equal to 7. I want to get x by itself. I need to move the 2 and the minus 5. The minus 5 is most by itself. So it comes across the other side as its opposite operation. So x over 2 is equal to 12. Let's move this 2. Comes over as times by 2. X is equal to 24. And one more. Now we could expand the brackets here. That's a perfectly valid method, but it is longer. Instead, I'm going to move this 3, this times 3. Opposite is divide 3. And rewriting it, I get x plus 5 is equal to 4. And moving the 5, x is equal to negative 1. Let's have a look at some other types of two-step equations. And these are going to involve square roots and squares. So we've got the square root of x plus 5 is equal to 7. Again, I want to get x by itself on the left-hand side. So I've got to undo this square root and the 5. I'm going to undo the outermost operation first, which in this case is the square root. Now the opposite of square root is square. So I'm going to cancel this here and square this side. And let's rewrite it. We've got x plus 5 is equal to 49. It's pretty easy now. Take this plus 5 over, becomes minus 5. X is equal to 44. Now have a look at this question. It's subtly different. In this case, I'm going to move the plus 5 first. I'm hoping you can tell why that is. Now rewriting it, I've got the square root of x is equal to 2. And now I'm going to move this square root. X is equal to 4. Here's a couple more. X squared take away 1 is equal to 8. I'm going to start by moving this minus 1 over the other side. And rewriting it, I get x squared is equal to 9. Now I want to do the square root of both sides. So cancel that and do the square root on this side. But of course I've got to do plus or minus. So x is equal to plus or minus 3. Because remember that 3 squared is equal to 9. But negative 3 all squared is also equal to 9. So anytime you take the square root of a number, you have to consider that we could have plus or minus the answer. And finally this one. This time I'm going to move that square first. So it comes over as the square root and it's going to be plus or minus. So we get x plus 3 is equal to plus or minus 2. Taking the 3 over the other side becomes negative 3. And I'm going to get negative 1 or negative 5. Now let's just have a quick look where that came from. I've got 2 take away 3 is negative 1, and negative 2 take away 3 is negative 5. Now let's move on to pronumerals on both sides. And we're going to start by collecting the pronumerals together first. And as a general rule, I will always move the lowest or least amount of the pronumeral to the other side because that'll avoid negatives. So here we've got 2x plus 3 is equal to x take away 1. So I'm going to start by moving that x. Now that is a positive x, so when it comes over the other side it becomes negative. So I've got 2x take away x is 1x, or just x, plus 3 is equal to negative 1. We're back to a one-step equation now. Moving this plus 3 over as minus 3, x is equal to negative 4. And this one, 2x take away 5 is equal to 5x plus 7. So I'm going to move this 2x. It's a positive 2x. It comes over as a minus 2x on the other side. And so I have got negative 5 is equal to 3x plus 7. Make sure that makes sense to you. Now I'm back to a two-step equation. I need to move the 3 and the 7. The 7 is most by itself. So over it goes. Now, be careful with your directed numbers. Minus 7 minus 5 is minus 12, or negative 12. So I've got negative 12 equals 3x. I'm going to turn it around at this point. Because remember that with equations, you can always swap sides. So instead of writing negative 12 equals 3x, I'm just going to flip it around. And our final step, divide both sides by the 3. And so our answer is x is equal to negative 4. And one more. In this case, I'm going to move that minus 4x. It comes over as plus 4x. And at the same time, I'm going to move this 7 over here. Now, if you want to do an extra line, that's perfectly fine. Rewriting it, we have 5x is equal to negative 6. And the last thing I need to do is get rid of this 5. I'm going to actually leave my answer as a fraction. So x is equal to negative 6 over 5. Now let's look at equations involving fractions. X over 3 plus x plus 1 on 7 is equal to 3. Now the first thing I notice is these invisible brackets, so I'm going to put them in. We could do algebraic fractions on this left-hand side and work from there. And that's a perfectly valid method, but I'm going to show you another method. I'm going to multiply each term by the lowest common multiple of those denominators. And the lowest common multiple of 3 and 7 is 21. So I'm going to times this one by 21, this one by 21, and this one by 21. And then I'm going to cancel. 3 into 21 goes 7, 7 into 21 goes 3, and 3 times 21 we'll have to do. So rewriting, I've got this 7x plus 3 outside of x plus 1, you can see my invisible brackets there, is equal to 63. Expanding the brackets, 7x plus 3x plus 3 equals 63. Collecting like terms, 10x plus 3 equals 63. Moving this 3 over the other side, 10x is equal to 60. Dividing both sides by 10, x is equal to 6. Let's try a couple more. This time we've got pronumerals on the denominator, but it's the same method. The lowest common multiple of 2x and 3x is 6x, not 6x squared. So I'm going to multiply every term by 6x. And then I'll cancel. X goes into x, 2 goes into 6 3 times, x goes into x, 3 goes into 6 2 times, and I'll do the right-hand side when we simplify. What have we got? 9 plus 4 equals 60x. Now I'm going to tidy that up and turn it around. 60x is equal to 13. Divide both sides by 60. And I'm going to write it as a fraction. X is equal to 13 on 60. And last one. This time we've got binomial numerators. Again, the lowest common multiple of 4 and 2 is 4. So multiplying both sides by 4, cancelling. 2 into 4 goes 2 times. Rewrite. X plus 3 is equal to 2 outside of x minus 5. Expand that right-hand side. X plus 3 is equal to 2x take away 10. We're back to pronumerals on both sides. Let's move the least amount of x, which is that one. 3 is equal to x take away 10. And then move this guy over this side. And I'm going to turn it around. X is equal to 13. Moving on to quadratic equations. Recall that quadratic equations can have one, two, or no solutions. So let's have a look at these three questions. The first one, x minus 1 all squared is equal to 0. Let's do the square root of both sides. The square root of 0 is 0. So x minus 1 is equal to 0. Taking the 1 over the other side, x is equal to 1. So this question has only one solution. Right, the middle one, again, we're going to do the square root of both sides, but this time I have plus or minus root 3. X minus 1 is equal to plus or minus root 3, and taking our 1 over the other side, I get 1 plus or minus root 3. So here we have two solutions. And finally this one, the square root of both sides. This time I get the square root of negative 1, which of course doesn't exist. So there are no solutions to this last equation. There are three methods that we use to solve quadratic equations. There's the factor method, completing the square, and the quadratic formula. The easiest way to solve a quadratic equation is to factorize and use the null factor law. So if we've got x plus 3 in brackets multiplied by x minus 2 in brackets is equal to 0, then the null factor law says that if we've got something multiplied by something else is equal to 0, either the first something is equal to 0 or the second something is equal to 0, because in either case it's going to nullify the other thing. We're going to go 0 times something or something times 0. So I want to say to myself, what makes this bracket 0 and what makes this bracket 0? X is going to be equal to negative 3 or 2. Now, of course, sometimes you're going to have to factorize first. So you might have x squared plus 5x plus 6 is equal to 0. And when we factorize, we have x plus 2 in brackets multiplied by x plus 3 in brackets is equal to 0. And then we ask ourselves, what makes 0 in each case? What makes 0 here? What makes 0 here? Of course, the answers are negative 2 and negative 3. How about this one? 2x squared take away 5x is equal to 0. Pretty easy to factorize, x outside of 2x minus 5. But when we go to do the null factor law, don't discount this part. We still have two parts to this. So either x is equal to 0 or 2x minus 5 is equal to 0. If you get stuck with this, just solve this. 2x minus 5 is equal to 0, take the 5 over, divide by 2. But you do start to see a pattern. This 2x has got to equal 5, so I need x to equal 5 over 2. So our answers are 0 or 5 over 2. So moving on to completing the square. It's a method that can be used when a quadratic expression or equation can't be factorized. So we might start with this. X squared take away 6x take away 5 is equal to 0. Now the first thing that I'm going to do is move this 5 over the other side. It's going to become plus 5, and I'm going to leave a gap. Now the rule with completing the square is look for the coefficient of x. In this case it is negative 6, and I'm going to halve it, square it. Now I'm going to take my negative 6 and then halve it and square it. We actually don't need to worry about the sign of it, because if it is negative it's going to square out. So sometimes I'll just grab the number itself. So 6 over 2 is 3. 3 squared is equal to 9. And that's what I want to put in here. Of course, I can't just do that. I can't just add a 9 to one side of an equation. I need to balance it and add it to both sides so that I haven't changed anything. Now we're going to complete the square here. This will be x minus 3 all squared is equal to 14. And we're back to one of those equations that we did before. Do the square root of both sides. Gives me plus or minus. And I'll end up with x take away 3 is equal to plus or minus root 14. And then finally take the 3 over. So I've got 3 plus or minus the square root of 14 as my answer. Let's try a couple more. X squared plus 4x plus 2 is equal to 0. So again, I'm going to move that 2 over. I'm going to look for the term in x, and the coefficient of that term is 4. And I want to halve it, square it. Well, half of 4 is 2, squared is 4. Whatever I do to one side, I have to do to the other side. Alright, completing the square. We have x plus 2 all squared is equal to 2. Now do the square root of both sides. Don't forget your plus or minus. x plus 2 is equal to plus or minus root 2, and then finally take the 2 over. X is equal to negative 2 plus or minus root 2. Now, if you end up with a question like this with a leading coefficient, you have to get rid of it. So I'm going to divide everything by 2 before I start. I am going to sneak this 7 over the other side at the same time, like this. So I've divided this one by 2, divided this one by 2, divided this one by 2. Now I'm going to complete the square. Here's the term in x. The coefficient is 8. Half of that is 4. Squared is 16. And add that to both sides. All right, complete the square. We've got x plus 4 all squared is equal to, I've just done this on my calculator, and I've left it as an improper fraction. Now, I'm going to do the square root of both sides, which I have a plus minus here, and I've taken the 4 over at the same time. It's only because I ran out of room. You might want to do an extra line in there. Now, the quadratic formula allows us to find the solutions, if they exist, to any quadratic equation. And it's just based on the general quadratic, which is ax squared plus bx plus c. Here it is, x is equal to negative b plus or minus the square root of b squared, take away 4ac, all over 2a. But it is given for you on your reference sheet. Let's look at an example. Solve x squared plus 6x take away 4 equals 0, giving answers to 3 decimal places. The first thing we need to know is that a, which is the coefficient of x squared, is 1. B is the coefficient of x, is 6 in this case, and c is the constant term, which is negative 4. Now all we have to do is substitute in. So we're going to have negative 6 plus or minus the square root of 6 squared, take away 4 times 1 times negative 4, all over 2 times 1. Tidying up under this square root gives us 52. And if we were asked for an exact value answer, we would leave it like that, although we could reduce that surd down. But we're not. We're asked for answers to 3 decimal places, so we have to put that in the calculator. We can't put plus or minus in the calculator. You have to do it in 2 steps. So minus 6 plus root 52 all over 2, and then minus 6 take away root 52 all over 2. And that gives us the answer 0.606 and negative 6.606. Moving on to inequalities. When an inequality sign like greater than or equal to, less than or equal to, or less than is used in place of an equal sign, the answers are not going to be a discrete value like 7 or 4 over 5. But rather a range of values like x is less than or equal to 1. So when we've got the equal sign in there as well, we colour in the circle that goes over 1, and then we want to point to the left for less than. Or x is greater than negative 4. So we've got an open circle this time because it's not equal to, and we're pointing to the right. We can also have an interval. So we say negative 1 is less than or equal to x is less than or equal to 4. Both of the dots, the circles, are coloured in because we've got the equal signs, and we point inwards. Or we can point outwards, and we would say x is less than 0, open circle, or x is greater than or equal to, coloured in circle, 2. So here's some new notation, particularly for year 11. Instead of writing negative 1 is less than or equal to x is less than or equal to 4 for this interval, we can use what's called interval notation. So we have a square bracket, negative 1, comma, 4, and then another square bracket. Now those square brackets mean equal to, or we can say bounded by. And this is the minimum, and this is the maximum. If we don't want it to be equal to, we use round brackets. So in this case, round bracket negative 1 comma 4 square bracket means negative 1 is less than x is less than or equal to 4. And you can see how we don't have the equal sign here. And in this case, we say not equal to or unbounded. So how would we write these two inequalities using interval notation? So the first one we've got x is greater than 3. And the second one we've got x is less than or equal to 1. Now, in each case, these two intervals are unbounded at one end. So this one starts at 3. It's not equal to 3, so we're going to have a round bracket. And we're going to do 3, comma, and that's going all the way up to infinity. And infinity is never bounded. so we have a round bracket. In the second case, we have a maximum of 1 and it is equal to, so we've got a square bracket and all the way down to negative infinity, which is never bounded, so a round bracket. Now an inequation is like an equation, but it has an inequality sign instead of an equal sign. And we use the same methods to solve inequations. So if we're asked to solve 3x plus 2 is greater than 5 and graph the solution on a number line, then just like with an equation, we want to move the 3 and the 2 so we get x by itself on the left-hand side. So the 2 is most by itself, so let's move it first. Comes over the other side as a minus 2, and rewriting it we get 3x is greater than 3. Then moving the 3, divide by 3, we get x is greater than 1. And when we're graphing the solution, we draw a number line and we put the number 1 in. We want greater than, so we just want an open circle, and we want to draw our arrow to the right. Now there are a couple of extra rules when it comes to inequations, and the first one is about swapping sides. Because looking at this question, 2 is greater than or equal to x plus 7, if this was an equation, I would just simply swap them over. But we can't do that with inequations. Here's the rule. When you swap sides with inequations, the inequality sign flips over. So have a look what happens when I switch sides. Can you see how the inequality sign has changed? It kind of makes sense though. Now let's move this plus 7 over, becomes minus, and so x is less than or equal to negative 5. The other rule is about multiplying or dividing by a negative. So let's go about solving this until we get into strife. We're going to want to move this 3. It's a positive 3. It comes over as a minus 3. I end up with negative 2x is less than or equal to 2. Now at this point, I want to divide both sides by this negative 2. But here's our second rule. When dividing or multiplying by a negative number, flip the inequality sign. So I'm going to get x is greater than or equal to negative 1. We can also solve inequations where the answer is going to be an interval, like this question. So we've got 3 is less than or equal to x plus 7 all over 2 is less than or equal to 4. Now same method, we want to get x by itself, but this time it's going to be in the middle. And we're going to perform opposite operations to all of the sides. So I want to move the 7 and the 2. The 2 is most by itself, so it's going to go first. Times 2, times 2. Rewrite. 6 is less than or equal to x plus 7 is less than or equal to 8. Now let's move this 7. Subtract 7, subtract 7. Negative 1 is less than or equal to x is less than or equal to 1. And when we draw a solution, we have negative 1 and 1. We have coloured in circles, and our arrows point inwards. Here's a harder example. Solve 4 is less than 1 minus x all over 2 is less than 6. So again, we want to move that 1 and the 2. The 2 is most by itself. Bring it over, it becomes a times by 2. And that leaves us with 8 is less than 1 minus x is less than 12. Now let's move this 1. That's a positive 1, so it comes across as minus 1. And I end up with 7 is less than negative x is less than 11. Now, we are going to multiply everything by negative 1. And of course that is going to flip the signs. And it would be kind of normal to write this. Negative 7 is greater than x is greater than negative 11. Except we never write it like that in maths. We would always put this negative 11 to the left. So what we're going to do is just flip the whole thing round and write it as negative 11 is less than x is less than negative 7. Now remember, we talked about absolute value in our first lesson on arithmetic, and absolute value signs strip the sign of the number. So the absolute value of positive 3 is exactly the same as the absolute value of negative 3, which is equal to 3. So if we're solving an absolute value equation, we have to consider two cases: that the expression inside the absolute value signs is positive, or that the expression inside the absolute value signs is negative. So here's one. Absolute value of x minus 8 is equal to 14. So our two cases are that x minus 8 equals positive 14 and that x minus 8 equals negative 14. Okay, we've got to solve both of those. They're pretty easy to solve. We can take this 8 over the other side. It becomes plus 8. So x is equal to 22. And same operation here. X is equal to negative 6. Now, don't forget you can always check your answers. So let's put the 22 in. We get 22 take away 8, which is 14. The absolute value of 14 is 14. Let's check this negative 6. Negative 6 take away 8 is negative 14. The absolute value of negative 14 is 14. So those are our two answers, x equals 22 or negative 6. Okay, last part on this lesson, and it's on literal equations, and they are equations with more than one variable. A really good example is a relationship like y equals 2x plus 1, which is a straight line relationship in a Cartesian plane. And you would remember that we can't find just one solution to that. We can find a series of points that will satisfy it. But here's the problem. Unless we have the same number of equations as we have variables, we can't find a solution. But one thing we can do is change the subject of a literal equation. So we might have a formula like a is equal to h on 2, and then in brackets a plus b. Currently the subject is capital A. But we could change the subject to h, little a, or b. So let's look at some examples. Change the subject of v is equal to pi r squared h to h. Now you'll find that a lot of the examples are going to be actual formulas like this one. This is the volume of a cylinder. I'm going to solve it like it's a normal equation. I want to get h by itself on the left-hand side. So my first step is to turn the whole thing around. Now I want to get rid of this part. I'm just going to use opposite operations. Divide both sides by pi r squared. And actually we've finished. H is equal to v over pi r squared. Example 2. Change the subject of f is equal to 9 over 5c plus 32 to c. Again, an actual formula that converts Celsius temperatures to Fahrenheit temperatures. So I'm going to start by turning it around so I get c on the left-hand side. And there are various ways to do this. I'm going to get rid of that fraction by multiplying every single thing by 5. And these cancel. So I end up with 9c plus 160 is equal to 5f. Now let's move this 160 over the other side. So 9c is equal to 5f, take away 160, and then finally divide by 9. So our answer is c is equal to 5f, take 160, all divided by 9. One more. Change the subject of a is equal to pi r squared to r. Again, another actual formula, this time the area of a circle. I'm going to begin by turning it around. We want to get r by itself, so let's move this pi. It comes over as divide. So r squared is equal to a over pi. Now let's take the square root of both sides. And r is equal to plus or minus the square root of a over pi. Now here's the thing. We know that this is an actual formula, and in real life, r can't be negative. But nowhere in the question does it say it's a formula. So we have to treat this theoretically, and we need to include the plus or minus. Okay, that's it. And our last lesson for this topic is on systems of equations.